Hello viewers, in today's class we are going to discuss one important definite integral involving greatest integer function, right? So here we have a very interesting problem, and here we have to evaluate this function, that is greatest integer 3x minus 1 from minus 1 to 0, right? So let us start. So here let us first call this integral as I, right? Now here in order to solve this integral, we can adopt two strategies, right? So we can make use of two methods. One is the methods of substitution, and the other one is the method of inequalities, right? So here in this problem we'll prefer the method of inequalities, right? So let us start. Now here we see that the limits of integration varies from minus 1 to 0, right? So x varies from minus 1 to 0, so x belongs to this interval, right? And now let us denote this function, that is the function which is inside the greatest integer function sign, that is f of x is equal to 3x minus 1, right? So when x belongs to minus 1 to 0, then let us see the interval in which f of x belongs to, right? So when x is minus 1, then f of minus 1 is 3 times minus 1 minus 1, that is minus 3 minus 1, that is minus 4. And when x is 0, then f of 0 is 3 times 0 minus 1, and this is 0 minus 1 minus 1, right? So here we see that when x varies from minus 1 to 0, then this function, that is 3x minus 1, it varies from minus 4 to minus 1, right? Now let us take the real number line, right? So here we have minus infinity, here we have plus infinity, and minus 4 it lies somewhere here, and minus 1 it lies somewhere here, right? And between minus 4 and minus 1 we have two integers which lies between minus 4 and minus 1, and the integers are minus 3 and minus 2, right? So here f of x, that is 3x minus 1, it varies from minus 4 to minus 1, right? Now our next step is to express this greatest integer function as a piecewise function, right? So now let us see the greatest integer function 3x minus 1. The value of this function is equal to minus 4 whenever 3x minus 1, this 3x minus 1, it lies between minus 4 and minus 3, right? So this is due to the definition of greatest integer function, and the greatest integer 3x minus 1 is equal to minus 3 whenever this 3x minus 1, it lies between minus 3 and minus 2, right? And the value of this greatest integer 3x minus 1 is equal to minus 2 whenever this 3x minus 1, it lies between minus 2 and minus 1, right? So now we have expressed our integrand which is greatest integer function 3x minus 1 as a piecewise function, right? So here the value of this function is minus 4 whenever this 3x minus 1, it lies between minus 4 and minus 3, and the value of this function is minus 3 whenever 3x minus 1, it lies between minus 3 and minus 2, and the value of this function is minus 2 whenever 3x minus 1 it lies between minus 2 and minus 1, right? So now the next step is to evaluate or to simplify these three inequalities, right? So now let us take the first one. So here we have minus 4 less than or equal to 3x minus 1 less than minus 3. Now adding 1 throughout, we have minus 4 plus 1, and we have 3x because minus 1 and plus 1 get cancelled, and here we have minus 3 plus 1, right? So this is minus 3, this is 3x, this is minus 2, and now dividing throughout by 3, we have minus 1, and here we have x, and here we have minus 2 over 3, right? So now this inequality reduces to this one, right? Now let us take the second one. So here we have minus 3 less than or equal to 3x minus 1 less than minus 2. Now again following the same steps, adding 1 throughout, we have minus 3 plus 1. Here we have 3x, and then we have minus 2 plus 1. This is minus 2. Here we have 3x, and here we have minus 1. Now dividing throughout by 3, we have minus 2 over 3 less than or equal to x, and less than minus 1 over 3, right? Okay, now let us take the third one. So here we have minus 2 less than or equal to 3x minus 1 less than minus 1. Adding 1 throughout, we have minus 2 plus 1, and here we have 3x, and here we have minus 1 plus 1, and this is minus 1, and here we have 3x, and here we have 0. Now dividing throughout by 3, we have minus 1 over 3. Here we have x, and here we have 0, right? So now we have simplified these three inequalities, right? So viewers, now we can replace these three inequalities by the simplified inequalities. So now this function that is greatest integer 3x minus 1, the value of this function is minus 4 whenever this x lies between minus 1 and minus 2 over 3, right? And the value of this function is minus 3 whenever x lies between minus 2 by 3 and minus 1 over 3, right? And the value of this function is minus 2 when x lies between minus 1 over 3 and 0, right? So now we have expressed our integrand as a piecewise function in which x varies from minus 1 to minus 2 by 3. Then we have minus 2 by 3 to minus 1 over 3, and then we have minus 1 over 3 to 0, right? So viewers, now we have to split this integral I as a sum of three integrals, right? I1, I2 and I3, and I1 varies from minus 1 to minus 2 over 3, right? So we'll write minus 1 to minus 2 over 3, and here we have greatest integer 3x minus 1 dx, and I2 is from minus 2 by 3 to minus 1 over 3, and here we have greatest integer 3x minus 1 dx, and I3 is from minus 1 over 3 to 0, and here we have greatest integer 3x minus 1 dx, right? Okay, so now we can replace this greatest integer 3x minus 1 in all these three integrals by the values minus 4, minus 3 and minus 2, right? Because when x varies from minus 1 to minus 2 over 3, then the value of this function is minus 4, and when x varies from minus 2 over 3 to minus 1 over 3, then the value of this function is minus 3, and when x varies from minus 1 over 3 to 0, then the value of this function is minus 2, right? So now we can rewrite these integrals as minus 1 to minus 2 over 3, and here we have minus 4 dx, then we have minus 2 over 3 to minus 1 over 3, and here we have minus 3 dx, and then we have minus 1 over 3 to 0, and here we have minus 2 dx, right? So now we have three simple integrals, and we can solve them. And see, here I is from minus 1 to 0, and we have 3x minus 1, greatest integer 3x minus 1 dx, right? So see, here x varies from minus 1 to 0, and see, here our initial limit is minus 1 and the final one is 0, right? So this is how we split our integral as a sum of three integrals, right? So now the value of this integral is minus 4, and the integral of dx is x. So now we have simply x, limits are from minus 1 to minus 2 over 3, and then we have minus 3, and the limits are from minus 2 by 3 to minus 1 over 3, and then here we have minus 2, and the limits are from minus 1 over 3 to 0, right? So here we have used the fact or the result that the integral of dx is x, right? So in all these three integrals we have x as the value of integral of dx, right? So now we can simply substitute the limits and we'll take the difference. So we have here minus 2 over 3 minus 1, and then we have here minus 3, and here we have minus 1 over 3 minus 2 over 3, and then we have minus 2 and 0 minus 1 over 3, and now we have minus 4, this is minus plus, so we have minus 2 over 3 plus 1, and here we have minus 3, then we have minus 1 over 3 plus 2 over 3, and here we have minus 2, and we have 0 plus 1 over 3, right? So now we can easily simplify this expression. So we have minus 4, this is 3 minus 2 1, so this is 1 over 3, here we have minus 3, and here we have 2 minus 1 1 over 3, and here we have minus 2 and 1 over 3. So this is minus 4 over 3, this is minus 3 over 3, and this is minus 2 over 3, right? So now if we add all these three numbers, we have minus 4 minus 3 minus 2 over 3, and this is minus 9 over 3, that is minus 3, right? So viewers, the value of this integral is minus 3.